This is the sixth video in our series of videos on basic nozzle knowledge, and this video covers fluid distribution from spray nozzles. In the previous video we covered the theoretical versus the actual spray pattern. So once we've actually worked out where the spray is going to end up, actually still be some variation in the fluid distribution once we've worked out where it's going to go. So why is this important? Some applications like coating, for example, need to achieve very even distributions of spray to achieve an even and consistent coating. For some applications, actually an uneven distribution of spray is actually important as well. For example, in firefighting applications, we have variable density of spray within some spray nozzles. That variable density can actually help carry more fluid through into the fire, overcoming heat currents. So it can actually be an important factor there to have an uneven distribution of spray. And for other applications, it's not really that important at all. So what affects the actual fluid distribution within a spray pattern? Essentially, it's all down to the nozzle design. General rule of thumb, though, is that the narrower the spray angle is, the more even the fluid distribution will be. If we put up this graphic here, we can see the fluid density distributions of various spray patterns in 2 dimensions. So looking face onto the nozzle, we've got 2 dimensions, we can see where that variation of fluid distribution occurs. Let's go through these. So for hollow cone nozzles, we can have either wide or narrow dispersal designs. And this depends on the design of the nozzle. So you get either wide distribution to a wide band of spray or a narrow band of spray. And that depends on the nozzle type. Now, full cone nozzles will tend to have naturally some additional concentration of fluid at the edges, and this amount will vary depending on the design of the nozzle. One specific thing to notice when looking at spiral full cone nozzles, these will have much more of that variation, and it'll actually be a kind of rippled variation throughout the circular spray pattern. This is because the spiral full cone spray pattern is made up of concentric overlapping hollow cone patterns, so we get that kind of rippled, uneven distribution throughout the pattern. This makes spiral nozzles not particularly good for things like coating, where we need an even application. But in contrast, it makes spiral nozzles quite good for the fire suppression application I mentioned earlier, because those bands of high density carry that fluid into the fire. Now, a mist or a fog nozzle, this isn't a true spray pattern. They'll either be hollow or full cone spray patterns that generate the mist or the fog, and that hollow or full cone pattern will be true very close to the nozzle. But as it turns into a fog, it'll actually start to even out. It'll be quite an even distribution of fluid within that misting pattern, but it'll be wafted around by air currents very easily because we've got very small drop sizes in that. So that will depend on where the air is going, so we may get some concentrations in one area or another. Flat fan nozzle, now these will tend to naturally taper at the edges, so we get a kind of even distribution for a big part of the fan pattern, and then it will taper off at the edges with less fluid being present at the edges of the pattern. And we can compensate for this if we want an even distribution of fluid on the coating application by overlapping flat fan patterns, so we get a consistent fluid distribution across the whole spray pattern. And some flat fan nozzles are especially designed to give a kind of square flat fan pattern with very little tapering at the edges. So there's some specialist nozzles that will do that. That's our video on fluid distribution within spray patterns. I hope you found it useful.